Hello, welcome back to another episode of the Reliability Gang podcast. I'm back with my right-hand man, Will Crane. How we keeping, buddy?
Doing very well, thank you very much.
Thank you for everyone that tuned into the last podcast about VA strategy. Had a really good response from that, you know.
It was a good podcast.
Do you know what? When I watched it back, I was like, wow, the power of being able to actually strategize a plan and execution. I think this actually goes for anything in life. Like, you can do something, but when you really strategize it out and really look at the elements of what you're doing and why, how much more effective can the end result be if you do that first bit first?
Yep.
And that's the thing. I think when we first started the business, we were very CM. That's all we did.
Focused. Well.
That was all we kind of did. So it was kind of come in, just test. And I think some customers got the instant benefit from that, but some just, didn't see the complete value because there was a lot of gaps missing in the process.
Yeah.
Do you know what I mean? And I think this kind of leads us into this podcast as well, because me and you were having a conversation in the car the other day, weren't we? And we see something on LinkedIn, not going to name any names, but you do see certain things and certain companies post certain posts and try to promote certain things. And it got us really kind of whirled up into this kind of understanding what is the best practice for vibration analysis. And no matter how much we seem to have that promoted in terms of what is the best practice, why is it, Will, that we're just seeing, even now, big companies as well, kind of almost showcase that they're not actually abiding by that ISO standard of what should be expected from the industry.
Yep. No, definitely. And I think that it probably goes back into the podcast that when we talked about CM strategy, we were talking about cost and the cost of sensors and things like that. And what we'll slowly discuss in the topics today is there's a few key points that are really important that we must do with vibration analysis to ensure that we're maximizing the potential of detecting the defect. And that does mean that there is a certain number of sensors that are best practice in order to detect the issue, depending on how far away they are apart. And we're going to explore that a little bit into how that then leads into digitalization and what that means. Because what we don't want to do is go and place sensors on it that record data 24/7 to record data from the wrong location and potentially miss a defect.
Valuable.
What's the value in that
point?
Whatsoever?
Yeah, 100%. Because, that goes back to what's the point in having something that can monitor more if the more is bad?
Yeah.
It doesn't make any sense whatsoever. And I think this is where we have to start being really careful when we go into this digitalization. Because what is the point in monitoring something continuously, but the result or the impact is actually worse than having someone go around and collect that on a routine basis? That doesn't make any sense to me whatsoever.
And I think this is the opportunity for us to kind of go through those really top level key basics that we always look to do whenever we're trying to implement a condition monitoring program or vibration analysis, because I think there's a lot of people that can, we've definitely seen it with a customer, me and Jamie have been out this week, where they were told that they had to fit these test point studs across all of the machines, and they had to do that for them to collect vibration data. For us to then find that they're not even using them, they've been installed in kind of the wrong location.
And they're in the wrong place. For them to say that they had to be installed which is a lie, you don't have to have these studs. Repeatability, we know, is a very important thing. Yeah. But repeatability, again, in the wrong place is not a good thing. Yeah. So we've got to also look, what we're going to look at today is we're going to go through some of the things we're taught in basics and vibration analysis, Cat 1. Why is it important to have a good mechanical transmission path to the bearing? What does it mean? Yeah. I mean, obviously, in an ideal world, it's very difficult sometimes on certain assets to achieve that. We know that. We know there's always a bit of argument within the industry about where we collect data on the non-drive end bearing. Yep. Is it a good mechanical transmission path? Is it a poor one? There's a lot of different arguments that we've seen within the industry. Is it better to take it from the fins, or is it better to take it from the actual bolt that goes into the housing? Yep. If the contact's not quite there, well, what is actually better? We've done quite a few studies with this as well, haven't we? We've done a few kind of tests because, even within our organisation, we've had conversations and debates about what is good and what is bad. But ultimately, sometimes it's very difficult to know. But what we do also need to emphasize, there is a standard, right? That should be kind of held to at all times when we can hold it to that. Don't get me wrong, sometimes we can't do exactly what that standard is, but we always should try to get to that standard. And the thing is, what we're seeing now is standards slipping really badly within the industry. And I'll be honest, right now, this day and age, with the knowledge that we've got, with the understanding that we've got, we shouldn't really be seeing it anymore.
It's resulting in we still have it now where customers are losing faith in the technology that should really be benefiting them, because they're missing issues, but they're missing defects because they're not being collected from the right location, or various other reasons. So there's lots that we can do. We've got the guidance from the ISO standard, and when we teach vibration analysis, the ISO standard that we're governed under, that make sure that we, and in level 1 we cover the topics of mounting of sensors and how that affects the frequency response. We cover the best place to position the sensors, all these kind of things. And I think it's important that for someone that doesn't, maybe an engineering manager that probably isn't going to go sit himself on level 1 but wants to bring a contractor in, what are the things that he needs to be aware of to ensure that really he's not getting the wool pulled over his eyes?
100%. And this also goes back to the fact that when we do vibration analysis, we've got this mindset in place when we're actually going to collect data. And as well, location is so important. Like, a lot of people will think, oh, it's okay because, we've got a sensor that's a little bit further away. But I'm telling you now, even with our vibration analysis handheld, we've got case studies, a bit like the bail opener. Right. Yep. Remember, we had that defect.
Yep.
We did see that transmit. Probably, I'd say, how far was that from where?
Probably just over 30 centimeters.
Probably 30 centimeters. And this is a big gearbox, by the way. Do you know what I mean? But if we were on the point of where we needed to be, I guarantee that the response would have been tenfold to what it was. This is the thing what people do not understand about envelope readings and mechanical transmission paths. When you get metal-to-metal contact, it's very localized, right? So that means even small distances away from that point will be far attenuated from where you actually get that point of impact, right? So this particular gearbox, we did identify it, but I'll be honest, where we were taking data from wasn't actually triggering our envelope alarm.
We identified it, and this was the customer that I was looking after at the time. We identified that there was a problem with it, but there was definitely an element of misdiagnosis with that gearbox because we were unable to test from the right
exactly location. So even us testing that, and it was a monthly test that we did.
That's me there on site testing it handheld as well.
Yeah, handheld with a high frequency response sensor. Do you know what I mean? Piezoelectric, and this is why it's so important to test in the right place. And it's also so important as well because when a lot of people digitalize their process, wireless sensors do cost money. Yeah. But a lot of people will say, oh, well, what we'll do, we'll just put one on the gearbox. I'm telling you now, guys, if you've got a MEMS-based sensor and you've got a gearbox that size, if you've not got that sensor on the money, you will miss the defect. So you can take data every single hour if you wanted to. It's going to be completely useless. And this is another thing as well within the industry we have to comprehend, because when it comes down to best practice, what we should be doing in the VA strategy is understand exactly where these bearings are, what they are, and where do we take the data from. And then do we end up making sure it's repeatable. So that process should still be followed, even if we're doing vibration analysis with a monthly or a continuous monitoring system. All of them things are still paramountly important. Yep. Just because you're monitoring it all the time doesn't mean that you need less sensors on the job. It is completely bonkers that we see this, but we do see it everywhere because the reason being, when the customers go invest in this stuff, in this technology, it's expensive.
Yep.
So what they try to do is try to mitigate and minimize the amount of sensors they require to keep the cost down. But then the cost of doing that is still far more expensive than having someone doing it properly and doing it regularly. And this is the problem with it, right? We should only really be investing in that technology should the failure modes mitigate the fact that that asset will fail within that monthly window, or the process mitigates the fact that it's difficult to get on a monthly VA survey, or the environment as well. This is the thing. We can't be cutting costs and we can't be saying, right, we want to digitalize the process. Let's put sensors on everything. Then saying, oh, we're going to cut the cost by putting less sensors on each asset and spread that blanket approach out. That's a very poor strategy. It's a poor strategy, because now what you're doing, you're actually there, your detectability is reducing because you have less sensors to identify the defects or positions within where you should be. And that's not limited to when we're taking data handheld. We can take as many points as we want to on that asset. Obviously, we want to save time, but there's always that argument of how many do we take and save in time. But at the same time, if there's no limitations of where we can collect that data, we can be far more accurate. Okay, there's less of it, right? And I'm not dismissing wireless sensors whatsoever. I love them. I think they're brilliant used in the right use case and scenario. But we would never suggest to the customer to go less sensors. We wouldn't. And if that is the case, then there's a risk, right, that is going to be a problem in the future, because they may miss something, and then who looks silly then?
But that has to be determined through the CM strategy and the criticality assessment, which needs to highlight whether or not the, putting a machine that let's pick the gearbox that we've been talking about here at the minute. We currently test 2 measurement locations on the motor, obviously both bearings, and we do 3 currently on the gearbox, which is the input and the 2 outputs, because it's an SEW helical bevel, but we can't get to the intermediate shaft just because of how it's mounted in the guard.
Yeah, of course.
So what that means is, though, is as we found with this issue that we had at the early part of the year, we've got to be aware that when our readings start to increase, we need to be aware that we're not testing at the intermediate side, and we may need to be aware that it's going to that defect there, when that starts to develop, will have to be more severe before we start to really see it at the top of the gearbox at the output.
And as well, you also have to consider that part of the gearbox is running at a slower speed. It's running at intermediate speed. So but when you're looking at input readings, it's going to be more sensitive to your envelope readings as well. This is why you have to consider, when you're setting your readings up as well, where should you be reducing your alarm levels depending on what you're monitoring. Doesn't all need to be the same. This also comes in the strategy part, right? When we do a proper strategy, we can also identify the speeds of, especially a gearbox. Say if you've got 4 or 5 reductions on that gearbox, the envelope readings on the input and the pinion gear are going to be far more higher if there is a defect than what you're going to find it further down the line. And that was a perfect example on that gearbox, because where we see that was worn, that gearbox, that was really very bad, damaged. Right? Very damaged, right? And I get, if we was on the right point, it would have definitely identified that, but probably at lesser amplitudes than what you'd find at a faster speed. So speed is also a very important metric to understand, but that is also identified at the VA strategy part. Do you know what I mean? Yep. I just feel like a lot of people are blanket approaching this approach, and they're not really thinking about all of the little elements that go along with it. And I think this is why we've changed our complete strategy now, because every single VA survey that we conduct, we will not touch any data until we've done a proper vibration analysis strategy, what identifies all of the defects, identifies where they actually probably do need other sensors that we can't detect because of certain issues. This is why it's so important to do that piece of work first. We got to understand exactly why we're doing it. We've got to understand, the benefits of putting an online sensor on, rather than just selling a solution that is not a solution. No. Do you know what I mean? A lot of this stuff right now in the industry is being missold.
Yeah. I think, like, if you're probably listening and trying to make some kind of bullet points, I think to summarize what we've just spoke about, you've got to first question and ensure that the test location of any vibration analysis, wherever that is being collected with handheld, or whether that's being collected with wireless sensors or continuous monitoring, wherever we're installing those sensors to monitor the machine, we need to ensure that we are testing from the correct location, and that we are not trying to reduce our test locations as a cost-saving exercise.
100%. That is nail on the head, because what we will do usually is say, this is how many points is required, right? If you look at most online systems, they are 100% reducing them test locations because of cost.
Yes.
But why you monitor it in the first place with an online continuous system if you're then trying to reduce the cost of it? Surely it warrants, and the risk of losing that asset would warrant the strategy anyway.
Sometimes there are going to be some assets where you probably can get away with putting less sensors on, but it has to be determined within the criticality assessment and the CM strategy that machine, the customer and the business is happy to accept the risk that the detection is going to be at the later stage of the defect. And if that the impact to the business is quite low. You just want to have an awareness that there's an issue, and you're like, okay, we're going to have to change that in a couple of days. That's fine. If you want, several months worth of notice because you've got shutdowns that you only have one a year, and if you're not testing in the right location, you're not going to get that level of early detection.
No,
you're going to get it at a later stage. If you've identified that in the CM strategy and the criticality, fair enough. But most places haven't.
But just go back to the gearbox example we had. Say we had an online system with the exact same sensor locations of where we're testing the data from with our handheld. Okay. Say then now there's another scenario and we're testing another gearbox, but we're testing it right on the point. Say there's a fixed sensor wired to a junction box. We're testing it monthly.
Yeah.
I guarantee that our testing from the right location when the defect goes, even though we're taking less data from that asset, would identify the defect far more early than having something constantly collecting data in the wrong location.
Yes.
It will.
It will. Especially when the location is just so paramount. I mean, even in the Cat 1 training, you're looking at approximately, I think the guidance is in metric, it's 150 centimeters.
Yeah.
Anything greater than 150 centimeters, really at that point, anything, so let's go the other way. Anything less than 100, if the two bearings are at less than 150 centimeters apart, you can get away with one sensor.
Yeah. But you still will see a attenuation from the point of where the
150 mil.
150 mil.
I was going to say, it's a very long thing. That's a very long.
Yeah, get that right. But there still will be attenuation because, I did a case study on LinkedIn ages ago. Got loads of likes, and it just goes to show when I was testing it, points 1, 2, and 3.
Post that you did.
Yeah, I did. I remember doing it because I remember seeing it, and it was also to really emphasize the fact that mechanical transmission path is so vitally important. So if you're going around collecting data, not really caring where you put in the sensor, and this is why as well we teach all of our engineers, and we also mark a location for repeatability, but also we've got to give that good common sense to the engineers when they are on site, because some sites, mate, there's some sites that we take data on, there's loads of assets, there's hundreds, so we can't glue a disc on for every single asset. It's just not feasibly possible, but repeatability is so important.
Not when you're serving as many customers as we do, it's not feasible. But it's an option that we can always.
Yeah, it is a good option. Don't get me wrong.
And if you're doing it at a site level, then total best practice. Let's put discs on everything.
And if you've got a good 30 assets on that site, it's easy manageable. Do you know what I mean? To be able to do that, and it is best practice, and that's something that we should be doing. But as well, first of all, what we do first is really educate our engineers about that data collection part. And we emphasize the importance of collecting data in the right place. We drum it into them. The first 6 months is about getting that bit right. And it's almost like, I'm so strict on it. Do you know what I mean? And I think that's really important to get right first. Because once you get into the habit of doing it right, then it's very difficult to go back, isn't it? You know what I mean?
You've got to push for that correct location to ensure that the defect can be identified.
And this is also goes into training of best practice, and also does kind of full circle go into, well, what about if a site wants to be able to take this on themselves? Okay, so we talked about test location points, and don't get me wrong, we've got some customers that do collect their own information, goes into the AquaM cloud, and we analyze that information. But when we do that, we always put discs on, always.
Yeah,
it's a no if they're not, because we can't trust that information should have been taken from a wrong place, and you lose that insight of having that engineer on site and having the eyes and ears, and we have to transfer that training into the customer. And that's why it's also really important that really, if that is the case, that whoever is collecting that data should go on the vibration analysis level 1, because it will teach them the basics and fundamentals.
It's meant for a data collector.
It's meant for a data collector. So don't get me wrong, some sites don't do it, but still do it effectively. But we always recommend it as a thing, because, I think it's really important, that part of understanding why it's so important to collect data from the correct locations as well. We're big advocates for it, and this is why we're doing this podcast as well, because we are seeing things inherently that are so wrong, and it's frustrating. Is it not frustrating for you? Because it annoys me. I'm not going to lie. I'm being passionate about this for a reason, because we've spent so long with like learning the proper fundamentals and the basics of vibration analysis and what is the right practice, and we teach it every day. We're in the culture, we live it, we breathe this stuff. And then when we see something that is so wrong just plastered everywhere from someone that shouldn't be doing it, it is so frustrating. Do you know what I mean?
It devalues the last 10 years of working towards ensuring that it's done correctly and trying to educate people about the right way of doing things. And
I agree, mate. I agree.
It's really important that, you know, whoever's providing your vibration analysis or condition monitoring program, that you can ensure that the right test location is being tested upon to detect the defect for that particular machine. So on the bearings for the motor, on the bearings in the gears for the gearbox, on the fan bearings, we're testing from the right location. And that's twofold, because that needs to be the right location for best transmission to detect the defect. That also needs to be best orientation to detect the lower frequency faults, because we've got to be aware that as we move the sensor around, it's not always possible to put the sensor perfectly vertical on some motors. It might be at an angle, but the analyst needs to be aware of that information to ensure that there's an understanding that the amplitude is going to drop a little when that happens, and that we're not putting test positions on for the sake of test positions, that we're just saying that we have to install them. We have to ensure that we're testing from that right location. We're not reducing down test locations to have a cost saving, unless we've ascertained in the CM strategy that we are happy for a later stage detection method. But it will be a late stage detection method. And I don't think when you're getting to those later stage of detection methods, you're kind of devaluing the point of doing vibration analysis.
You are, because, you know, you have to look at most plants and practices. It is very difficult sometimes to just, you know, get something planned in, scheduled in. It is difficult because you've got production, you've got a lot of constraints. Like, this is the thing that we first found when we was doing vibration analysis. A lot of questions were like, well, why have they not done this? It's not as if they didn't want to, but there's a lot of hoops to jump through the other side of it. And we never really got that from, I think you did actually, because you worked at a factory. You was in there. I never kind of understood it at first. I was like, oh, they just should do it. You know what I mean? And don't get me wrong, the information was valuable to a sense, but there's so many constraints I've learned from that point that don't allow the job to get done. You know, it needs to get planned in. You need to get the parts. You need to have the availability. You need to make sure that, you know, you've got a window to be able to do it. You've got a lot of things that needs to be planned. It's not just straight from information to done. There's another process from that information going in to the other plant's strategy. But that's also why we got involved with reliability, because what we found was, it wasn't the fact that plants didn't want to do the things we told them. It was the fact that within their process of receiving that information, they really struggled to be able to organize it to get to the end result. And that is because of their maintenance strategies within the plant. And also it's down to the fact of their organizational structure. Do they actually have a planner scheduler? Who is the engineer and manager? Is he doing all of the jobs that he's so snowed under to be done? And this is why we got involved with reliability as well, because we realized that, okay, there's a reason why they're not getting from A to B. Right? There's a reason why. And that's when the other reliability part come in for maintain, because we understood that, great, we want to help people identify. We love doing that. But what we get the kick out of is the actual defect coming out, seeing the defect, improving it, and being a part of that process. So Solve allowed us to be able to help the companies actually plan that bit. But at the same time, the improved part coming from the understanding where they struggle within their organization to be able to do that. And then we can advise them how they build that in-house. They can't outsource that to us forever. That needs to be built from inside. That's something that we need to have a look at externally and try to say, look, because sometimes when you're in something, you can't see it. You know what I mean? You can't see it when you're in it. But when you step outside and you're like, right, let me gather the information, you're like, oh, there's 2-3 key problems here that's not allowing you to get where you need to be. So that oversight as well allows us to be able to do that part with the reliability bit. But again, I'm going off tangent anyway to a degree. But when we come back to best practice of what we're doing, you have to also remember there's a long route to be able to get to the solution with any problem. And this is why reliability and this industry is so complex to a degree, because it's not just one thing that we can do our end that ends up in the solution being solved, if that makes sense. But if we don't start at best practice, if we don't take the data in the right place, if we don't actually allocate the right number of sensors and do the VA strategy bits, how the hell are we ever going to get to the end result? Because that's just the first bit. That's just the first bit.
Yep.
There's this huge part in the middle that we're trying to get involved with. And this is why it's really difficult actually to have a reliability business. It's so difficult because the problem is everybody out there is calling themselves a reliability company. And then when you look at what they're actually doing, they're not doing reliability whatsoever.
They're just trying to detect defects badly.
They're just trying to detect defects. How many companies do we see reliability, but you look at what is actually reliability. What does it mean? What does it mean to be a reliability company? And we threw ourselves into this. And it is not easy. It is so difficult. You need so many skills. You need to be able to tackle culture. You need to be able to tackle like awkward conversations when you know the CM that you're doing is adding no value whatsoever and the company still wants it anyway.
It would be easy just to go in, collect data,
and just
issue
go
a report and
say, see you later, go. But that's not what is in our hearts. But the thing is, like, I don't know what it is. It's a challenge, but also really just gives me this buzz because it is hard. Like, I don't want this to be easy, right? You know, they say there's a saying, like, don't wish things to be easy, wish to become stronger. And I think within our position right now, I think we are having a bit of a breakthrough. I do feel that breakthrough happening.
People
and I think
changing their mindsets towards things.
Yeah, it's been such a hard 2 years. I'm not going to lie, and I'm going to say it completely how it is, even on camera. That, you know, sometimes we have these conversations, like I'm hitting my head against the wall because it's like you feel like you're getting somewhere with certain companies, and then you go back to square one very quickly, and you're like, "What are we doing here? What is the point in this?" It can be so demoralizing, but there's something deep down in me that always does also know that at some point things will change, culture will change, ideas will change, and it's refreshing on LinkedIn because I've had some great conversations, and this is why I love this podcast. I love it because we get the feedback that there are people that are in the same boat as us, and they're like, no guys, keep doing what you're doing, keep doing the right things, keep pushing the reliability mindset, and that's what keeps us going. That's what keeps us rolling into, and we're never ever going to stop and change the ethos of our company. We're not, because we have transitioned into that reliability company now, and that's what we're focusing on. And I think what we're now going to do is still push that identity for what we are and maintain reliability. And this is why when we do podcasts on best practice, we're going to say it with our chest. We're not going to shy away from the conversations. Do you know what I mean? We're not going to just be politically correct and not, we're going to say what we believe and what we feel and what is right for what we think is right in terms of reliability. And that's what I think what the industry needs. I think we need someone to come in here, shake it up a little bit, and tell some hard, honest truths about the way we push this forward. Because until we get past that culture conversation, we're just doing the same things and we're not changing anything.
We shouldn't be pushing to, you know, we should definitely be encouraging to digitalize. I think it's the way forward. We're really excited for that opportunity, but we shouldn't do, you know, there is a cost to digitalization, and we've discussed it before in previous podcasts, and that cost is generally going to be greater than having an engineer go to site and collect the data. Albeit they need to be skilled, and, you know, we struggle with getting the right people. It takes time, but you're always going to find that right now is going to be a more cost-effective solution, unless maybe the CM strategy has identified that the failure rate requires more monitoring than monthly. That's always going to be more cost-effective than putting sensors on. But we want to push for digitalization, and the technology cost is getting more cost-effective to allow a point where we can put the right number of sensors that should be on that machine to monitor it. But until that time, we shouldn't be just throwing away everything that is taught within vibration analysis, level 1, all the way through to level 4, the basics of good sensor mounting, the basics of good test location, the basics of frequency response, sensor type, measurement parameters, all of this. We shouldn't just go, we're going to forget all that because we can't quite afford to put all the sensors on, but we're going to get more data. Like, it doesn't matter how much data you get, if it's not from the right test location, it's not using the right sensor, it's not been identified as to what it's trying to prevent, it's pointless.
It is. Crap in equals crap out. Doesn't matter how much crap you're putting in, there's a lot more crap coming out. We have to get back to the fundamentals. We've got to get back to the basics, not forget where we come from with this. I think, to be honest, when we first started this, there's too much purists involved. It was all too very much that way. But I feel like we've completely chucking everything, all of that in the bin, and we've gone too far the other end of the spectrum.
Like, obviously, we're talking about, this because it's become more relevant of a topic recently. But, a year, 2 years ago, the IoT and data and MEMS-based sensors, I remember, was blowing up quite massively on LinkedIn at the time. And I felt like we were regularly, with, politeness, just raising concern to many, many posts on LinkedIn. It was different companies, one sensor on a 15 kilowatt motor, and we were commenting on just saying, no, guys, this isn't the best practice. And I felt like we got away from that. We hadn't seen that for a number of years. And then we've seen it again recently, again now. And it just highlights not just the importance of sensor placement, the correct location, but the importance of understanding that as we do move within a digitalization world, it's not an excuse to just put sensors on and forget about the machine.
100%. And as well, we also have a responsibility. This is something that we can't forget.
Yeah.
So when me and you've gone through this, like, education, and we've lived and breathed this, and we've learnt it, and we've got the accreditations, we've done the vibration analysis level 3. When we do see it, we do need to educate.
Yeah.
And it's not that we're having a go at anyone, right? That's never that. But we do need to question it to educate the industry. Yeah, because what we can't have is all these posts going out and people thinking it's acceptable.
Yeah.
Because it's not.
No, and at the end of the day, any business that works within reliability, or say they work within reliability and condition monitoring, has a responsibility to ensure that what they are sharing and what they are delivering to their customers, they are well educated. If we've got a customer that's like, guys, we want to put sensors on anything, it's a big part of the business plan is to digitalize the plant. The budget is not quite there yet until we get a return on investment, or we demonstrate the bargain. How many sensors have we got? We talked about this customer with the gearbox. We're now actually looking at putting sensors on these gearboxes. We may look to put 3 or 4 sensors on, and the best might be to put 6 on. Okay, it's fine that we may look to reduce the sensors, but there has to be the conversation piece. There has to be the understanding of what limitations that brings. What does that mean for the results? What does that mean for the end goal of all of it? And if that's discussed and the business is happy to take the risk and we're happy to make that decision, then we've done that as a collaborative approach. Yeah, and we're not saying...
We've not just sold it, have we?
No.
We've gone through the risks, we've gone through the best practice, we've had that conversation. The thing is, right now, people are not having them conversations.
And it's understanding as well, the most important is that if you've got reliability in your name, you can't just be putting sensors on things and being like, yep, we're collecting data all the time, we're detecting issues. That doesn't make a plant more reliable. What makes a plant more reliable is understanding that if the customer wants to digitalize, or if we're going to collect vibration data, handheld or whatsoever, that if we have a focus on reliability, therefore, if we are collecting data and the machine is in a poor environment, it's getting covered in dust, or it's covered in oil, or whatever is happening to that machine that is potentially damaging its reliability, it's reducing its life, whether it's being collected handheld or not, needs to be understood. In that CM strategy part that we do, and I'm sure we'll share some bits that we're now putting together, it needs to be identified that this machine is in a poor environment and there needs to be some improvements made before we just stick sensors on, or before we need to just...
100%. And that's when we do CM, we do need to look at PM optimization, PMO, and we can do that as a perspective as well by looking at the reliability
and additional
stuff.
PMs
and additional as well.
Check these sensors.
Exactly. And that's the thing about self-lubricate, it's the same thing. Yep. We've just seen the same thing being copied with the wider sensors.
Yeah.
Self-lubricate and stick on, see you later. How many times have we seen self-lubricate? I've had one with a service company. I have no idea about lubrication. Putting on one lubricate on the motor that's got 2 bearings that are greasable, right? It's a belt-driven application. And they've put one on the non-drive end.
It travels through to the drive end, doesn't it? Just goes through.
But this is it all. I'm just like, what is going on? And I'm talking to these guys, and I'm like, what is in the service contract? And then I find out how much they're paying for these service contracts, and I'm just like, this is criminal. This is criminal.
And I think they're
paying to destroy their machines.
Yeah.
It is just criminal, and I just don't agree with it, because the thing is, right, you might say, okay, there's an educational piece they need to learn. You cannot go put on a self-lubricator without not knowing the impact of what it could have. It's just a bit like...
It's a bit negligent.
It is negligent. And it's frustrating, because we've come in there and we've identified all of this, and they're scared to take them all off. They're scared. I'm like, you need to take them off now. You are, and we changed 2 of these mowers, and both of them had severe fluting on.
Yep.
Okay, I get it. The root cause wasn't directly associated, but what was happening was that over lubrication was causing this to accelerate. You could, and you're not being funny, the grease, you could see it in the winding. I mean, that was so lucky that didn't just foul.
I mean, like, as you can tell, we're quite passionate about this. And I think that we've just got to, the best we can, through this podcast, through LinkedIn, we just want to be able to
this is our venting ground. This is like...
If we
it's like meditation to me.
If we can just be able to just make people aware, when there isn't best practice being followed, and do that in a way that highlights it and share the things that need to be taken into consideration when doing that, I think it's just important.
Yeah, and what I would say as well, if you've got a company, and don't get me wrong, there's a lot of companies that sell self-lubricators, a lot of supply companies that do, and all the rest of it, and they're there to sell products. I get it. Their main business line isn't reliability. It's not. They're there to sell. But if you're looking at lubrication strategies, if you're looking at condition monitoring, we're looking at reliability as a whole, them 3 things, you need someone who can look at the whole picture and understand the impact of installing some of these things. Because just buying some self-lubricators and chucking them on will not solve your problems. If anything, that approach will cause you issues and problems. I'm not saying self-lubricators are bad either. I'm not. I think they're great if they're A, set up in the right way, B, you've got good PMs to check that they're doing what they should be doing, and you've got constant people looking at these things. And this is the thing about this whole automated society. We can't go to the stage of where, I get it, in premises, that's what we want, isn't it? We want to be able to use technology, machinery, and smart applications to be able to do things autonomously. We do. That's the whole point of it, because it saves time and money. But the problem is, a lot of this stuff is being, in premise, a great idea, but being thrown on these assets, but without the right setups with these things and the right checks. And I'm not saying that you have to check a self-lubricate every day. You know what I mean? It might just be a monthly, is it working? Is there any grease dispensing? Quick PM check around it. The problem is we're getting negligent, because what's happening is we don't have robust maintenance systems in the first place. And the problem is we've not really assessed them strategies in the first place. And then we're coming in and installing some of these things that are automating the process, but we don't even have the robust maintenance strategy anyway. And that's when it's falling down. I can guarantee people that do have a good, robust maintenance strategy before these things come in place, they have the biggest chance of success of using these things to their advantage, because they already have the mindset of checking things, making sure they're okay. So again, self-lubricators, online sensors, I'm not crapping on them. I think they're great when they're set up correctly and used in the right use case. I think they hold an immense amount of value, but they've got to be done in the right way, because if you don't apply that to it, you will end up being in a detrimental position for it when you're trying to make a better difference or better use case with it as well.
Yep, agreed.
So, guys, I think that wraps up today. I'm going to go, I feel better now.
I can tell you vented.
Yeah, I just had to release some energy out. But, guys, I know it can be quite animated, but I am passionate about this. I do love this game. Honestly, we're just so in it. We're so involved with it. And I think this is important that we also have the real element of how we feel about this type of stuff, because I don't want to sugarcoat anything anymore. I don't want to, do you know what I mean? I just want to be able to say how I feel about it and just try to make sure the passion's there for the industry, because I think it's going to be beneficial in the end, because everything that I say and Will says is out of the good intention of reliability and the best practice. So if we can communicate in that way, then why not? Do you know what I mean? So guys, thank you for tuning in. I don't know what we're going to do next.
Don't know. We'll come back to you.
Yeah, we'll come back. We're going to have a little thing. Something
we'll wait for the next thing.
Something will trigger us and we'll be straight back with a bang. But guys, thank you for tuning in. Take care.